Hey guys. Welcome to Broadening Implementation Options of a .NET Framework by adding a JavaScript SDK. Microsoft lawyers, don't kill me. So if you're here, it's because you're interested in learning about the journey that we went through as a .NET platform to make it more JavaScript friendly. My company has a platform that lets clients build websites using, and it's a .NET backend. It's all .NET SQL. You have to be a .NET developer to implement our platform. So traditionally, it has not been very friendly to a front-end workflow. And so what we've done is we've built a whole new way to drive implementations so that we could be more open to different types of developers. So in this presentation, I will share our experiences and highlight our learnings for other teams who may be building JavaScript libraries. So please bear with me for the next couple of minutes, as these next few slides will sound a little bit sales pitchy, but I just need to set the context for what my company does to explain the problem, and I promise it will get better after that. So my company is global, and although we only have 1,000 employees, through our many partners, we collectively have over 18,000 developers. And the interesting part is that these are all C# .NET devs who are working in Windows generally, because while they're building these sites, they usually install the platform locally on their machines. And if you're like me and you like to work on a Mac, that usually means that you have to install a VM. So what does what we build is basically hyper-personalized websites. It's a content management system on steroids, as I like to call it. So what does a CMS user, a client who's using our software, need to do to build a page in their website? So a website consists of components. And if you've worked with the JavaScript framework in the past, then you're familiar with the idea of component composition. The special thing about component composition in a content management system like my company's, like Sitecourse, is that the CMS user, the author, not the developer, is in charge of the composition, because they have to be able to go into the interface, build the pages, and assemble the components however they want, make edits, enter it into workflow, ask for approval, make changes on the fly. It's not up to the developers. So let me show you what I mean by that. So this is something that an author might see when they're creating a new page. They might just go in and see a big giant placeholder. And then there's some buttons there to add a new component, right? So some screens might pop up, some GUIs from our platform with a whole choice of components that developers might have built in the back end. So as they're building out these components, as they're going through this UI, they can add additional placeholders to build out their layout, add new components, edit the content right there in line in the editor. They can switch stuff around or take components totally away. Like I said, the composition is totally up to the author. And the interesting stuff is that placeholders can be nested inside of components too. So they can just put stuff however they want. Once the page is assembled, the dynamic element of what the content author is doing doesn't end there. So then they can click on the component and add extra options and rules on them. For example, they might want to personalize how the components are showing up to the end user. They might want to say, for these components, switch out what you're showing based on which user persona is viewing your website. Or maybe if the user is in this country versus in this country, show something different. Show a different social website. Or maybe they want to do some kind of A/B testing on the stuff on their site. So the bottom line is we don't know what's going to be on the page at development time. That makes it really difficult to build stuff in front-end frameworks, which kind of depend on that. The way that this works in traditional .NET MVC development is that everything, all the component blocks are just MVC renderings. So all the HTML snippets are in MVC Razor views. So when they're sent to the content author for editing, because the content author needs to be able to add rules to them and move them around on the page, we have to add special sprinkles to them to make that happen. So we wrap the HTML of every component in some extra stuff. But that means that that all the HTML has to be server-side rendered, and it has to be a discrete modular piece. Once the author is done, we take what they've done and send it back to the server and save it in the database, no problem. From the front-end side, the end user makes a request to the server, and we just send them the raw HTML, and in that case, we don't need any extra sprinkles, no wrapping of HTML needed, so they just get the raw Razor HTML, no problem. So in this MVC workflow, the JavaScript ends up being dependent on the MVC layer because the Razor views have all the HTML. So the JavaScript devs and the backend devs end up stepping on each other's toes as they're making changes in these parallel workflows. Since MVC is a backend developer thing, and backend devs end up in control in terms of how models are structured, how the backend endpoints for AJAX are structured, it's just not an ideal workflow for front-end devs, and the back-end devs just really end up being in control. So although this is not perfect, that workflow has worked for us for over 20 years, for almost 20 years. But we went and reinvented it because we wanted to pull in this new audience of developers, and we wanted to make our platform accessible to all different types of devs. And I'm careful to say that we evolved, we didn't change, because the traditional approach is still totally valid. We've made it so that you can implement in both types, in MVC or as a front-end dev, just totally driving everything with JavaScript. So Satya hit it perfectly in this morning keynote when he said that enjoyable software is about putting people in the middle and seeing how people use the software, as opposed to putting technology in the center and seeing what the technology allows. So yes, he was talking about Office 365, but I think this totally applies to devs too. For any company that builds apps, APIs, or tools that are used by teams comprised of different dev types, we need to make sure we're being inclusive to all the devs. This increases the talent and technology stack diversity in our software, which is what drives innovation and cross-platform scaling. And the end users are the ones who benefit in the end. For us, that meant that C# and JavaScript became equal citizens in our client sites. So we were able to take advantage of well-known front-end framework features like more efficient downloading, well-defined patterns for project setup and data management, and of course, open source libraries and tools and all the good stuff that comes with many years of open source projects with thousands of people behind them. So what's even challenging about implementing front-end frameworks in a CMS? So as I mentioned, front-end frameworks are awesome, but they assume a particular workflow, and that is that devs are controlling the component composition. So making that part dynamic required some customization. Here's a closer look at what I mean by the composition needing to be known at development time. I took these samples from the documentation of the 3 main front-end frameworks. They give examples of how code needs to be nested to support nested components. And for all of them, everything is defined explicitly in the code. And when you do have some kind of dynamic components, it's usually hard-coded rules, so you'll have some kind of if statement in your React code, for example, that switches a component at at page front-end time. So it can't be something that's totally dynamic based on what the author is placing there. So what we build, and we call it JavaScript services, it's a set of NPM packages and app starters that make it possible to build JavaScript apps powered by dynamic server-side layout data. They stay true to the headless CMS concepts that allow JavaScript devs to work independently and be in control of their front end, while preserving all the editing and personalization capabilities that I showed you from our traditional approach. Before we dive into the architecture details, let's get an introduction to the code. So this is a sample application that implements JSS. This isn't JSS itself. So I'm importing JSS, and at first it just looks like your standard React app. It has source with all the components. They're just React components. This is actually based kind of on Create React App. We're extending it to make our starter apps. But let me jump to this home container component. And the interesting thing here is that we have a helper component from our library called Placeholder. So this is kind of how we define the holes in your front-end code. So we have a CLI command called JSS start, and when I start that, it launches the application locally. So it's similar to the start in Create React App. So this is just a sample, a really simple demo here, and I'm just showing what it does because I'll bring it back later in my presentation. But it's showing you a list of sporting events, and they're repetitive here because they're pulling from test data in my project. And of course, with the start app, we have hot reloading, and if I change some code in my React app now, we'd see it dynamically refreshed in the browser. So same thing as your standard Create React app. So the SDK started because a few of our devs had some good ideas about JavaScript, and they pitched this to the company. They were really determined on having this be an open source. So they started talking about that right away. So if you're a company who doesn't normally do open source and you want to go in that route, we recommend driving that idea right from the start. And the goal of the initial POC was to prove that if we replaced with the MVC layer with a React app, that we could render it server side and thereby attempt to preserve the authoring capabilities. So this started us on this 3-year journey from assembling a team to ironing out the architecture, to iterating on several versions of a public tech preview where we gathered feedback from the community. So we think that's also an important part of building a new layer to your software, to getting that input from your developer users. So remember that the author's page editor, for the author's page editor to work, the server needs to deliver the components HTML, so we can wrap those in those extra sprinkles so that the author can get that UI for setting the rules on dynamic functionality. So our idea was that what if we could build a React app but render it server side, so we could still basically do the same thing. So in this diagram, we get the layout data from the author. This is something that was already happening. The new part is a custom JavaScript controller that serialized the dynamic layout data as JSON. A small node server rendered the app using the layout data and sent HTML back. The React app was a standalone project, so we achieved unplugging from .NET and defining clear front-end and back-end separation. As for how the React app consumed the layout data, the team built the placeholder component. This is the most basic example of how the placeholder component is used. So the placeholder is given a name, in this case JSS main, and it's just a hole that can be filled with anything. let's take a look inside the JSS code to see what the implementation looks like. So we have packages for each one of the frameworks that we support. So for example, you guys, does it only show my one screen and doesn't switch? But I'm still on the same computer. Oh, I got it. Because I have to switch to here. Nope, that doesn't switch it either. Can you come help, please? I needed to go to the code.
Is it? So yeah, it's whatever you're projecting out to here. Do you want to just drag it over to the other screen? So that's what you did that last time.
All right.
Just make it big.
Yeah. I have 3 of them. All right, thank you. All right, so we're talking about how the placeholders are implemented in the backend. So we have packages in our JSS SDK for all the front-end frameworks that we support. So for example, we have React, Vue, Angular, React Native. So I'm going to use React as the example. So if I go into the placeholder helper here, and all of these placeholders are pretty much analogous to MVC HTML helpers. So in the placeholder helper, so it starts off with getting something called the with component factory. So if I jump over to the application that I showed earlier that was implementing JSS, which is that site with the list of events. So whenever the front-end dev adds components in their application, so here they all are. So just from them having the components here in this folder, in their starter app, we have a script that will look at this folder, and just based on the naming conventions, it will find all the exported React components in this folder here. It looks through, and then it generates a file that maps names to components. So it looks something like this. So this file is generated. And of course, if people don't like the default structure convention that we expect, they're welcome to change this, because this is a script that's in the front-end dev's implementation. So in this component factory, names of components are mapped to actual components. So this is how we know when we're getting the layout data of what the content author has put into our holes. We know what we have to initialize dynamically. So going back to our placeholder component, we get the factory. So we have the power to initialize anything we want. And going down here, so this is where the magic happens. So it's going to loop over everything received from the server, all the layout data. So on page load, all of the dynamic layout data, it's going to loop over it and initialize what needs to be initialized. So this is the most simple way. So if it's just a hole with a bunch of stuff inside of it that's been declared in this simple way, it's going to use this function here. Which will just loop over the components and aggregate all the props and pass them in. But the reason we have all of these other if statements and all these other ways of rendering placeholders is because React devs also want to have additional ways to render the components. They also want to be able to work with things like render props and higher order components. So one of the things we had to do to support multiple frameworks is to find all of the way that components can be composed and nested. And in our placeholder helpers, we had to build in ways to support that. Yeah. So over time, we made some improvements to the architecture, which is changing that JavaScript controller to its own service. And that made it more flexible, since it can be called as a REST service from any context. And the node rendering engine was externalized, so it could live on a totally different machine from the layout service. It still receives layout data as JSON, but now this happens as an HTTP post. The physical decoupling of the rendering host means that it's now possible to develop on a Mac against a remote platform instance. So with this architecture, we solved the challenge of needing to keep authors in control of layout, and we've enabled front-end devs to work from any operating system. But so far, they still need a remote platform instance to serve layout data, so they still can't work totally independent. What if we could totally disconnect them and let them work from without .NET devs and without Windows at all? So we built something called disconnected development. So this is something that happens at the start of projects. And this is really powerful because it lets JavaScript devs mock all the .NET bits and define their own layout data during development. So how this works is, so the JavaScript devs are still, building their isolated React or Angular or Vue application that's running, that's being run with Node, and the idea is that it's going to be server-side rendered. However, when they're running locally and they need to mock what's ultimately going to come from our .NET platform, so the concept is they'll be creating static YAML or JSON files to define the schema of that layout data. And they provide sample data of that will fill in sample data for what the author would normally populate. So for example, So this one here is the code for that sporting events website that I showed earlier. Where's my mouse? Mouse is gone. There it is. So here's what I mean by creating static files to mock what would normally come from the server. So this is the home page that we saw that was showing the listing of events. So once the front-end dev built out all the components in React, then they would come here in this data folder, which represents their temporary static mock data, and they will build out all of their routes. So in the home route, what they're saying is there's a placeholder called hrefnav. On the placeholder, there's a component named navigation. They're able to nest the components and fill out fields that a content author would fill out. So then we have I think I lost my mouse again. Sorry, guys, this is not. There it is. So in our JSS code, we have a command line helper. So I'll close the placeholder stuff. So it goes through. Okay, so it's the manifest package is what does this. So the manifest package knows how to look at the YAML or XML files that you created. It knows how to read them. It knows what the different lines means. And then from there, it knows how to generate a JSON file of what your layout looks like. So from field types to, it will come here and literally write a JSON file on your file system with your mock data. So it would look something like this. So we've created our schema for our models, for our components, for our placeholders, everything that would normally be done by backend devs and then by content authors, but we've done that as front-end devs. So the next step is to actually plugging that into our localhost Webpack configuration. So normally we use Webpack dev server to just run our app on localhost 3000, but when our app is running, it needs to make calls back to our layout service to get this layout data. So what we're doing is we're spinning up an extra express server to read the static manifest and process our requests and return our fake data back. And we're using some middleware to set up that proxying. So let me show that. So this is the app that's using JSS. So it comes with a script to set up the proxy. So if we call, okay. So we get a command, JSS start, and that's what I called earlier when the site came up locally. So what we're going to do first is set up some variables for our environment, like what port to run on and what host name, since the variables that we use in our local mode is different from variables that we would use in a higher environment. And we have to tell our proxy about that. Webpack has a way to do that natively, but we wanted to kind of wrap that functionality a bit to make sure that it works in the same way across all of the different frameworks and to make sure that it was easier to maintain. So that's why we are kind of doing this step manually. So once we've set up our variables, so then we just run start React. So that's just basic start React from the create React app. And then we're starting our proxy. So starting the proxy is, it's using this node module. And so that goes to our JSS code, which is here. So that launches an Express server that takes in all of the configuration that we defined in our app. It creates a manifest object, which takes our manifest JSON file, loads it up into memory, and so now it's able to process our requests and feedback layout data on the fly. And here is the actual proxying code. So anytime that our app tries to go to the back end, we are able to intercept that request and give it data back. So that's how we're mocking as though we're working against a real back end, but it's all totally disconnected on a Mac. No platform installed. You know, I don't have to wait for some backend dev to set up an integration environment. As a JavaScript dev, I can just be up and running in four commands. And this is just showing that when my local app was running, if I look at the network tab and I see that manifest data is coming in, and it looks just like it did in our manifest JSON file that was generated locally. And so this data is being fed into the props of our React components. So they're all being hydrated with this layout data, and the page is being populated dynamically based on what the author would have put together. So when it's time to bring in the rest of the team and start adding the .NET bits, the JavaScript devs push their code, including the manifest to source control. And then that's pulled down in the integration environment where it generates the manifest and does an import task. So everything the JavaScript dev built in terms of modeling, information architecture, all that gets persisted. It goes into the database, and now that it becomes the starting point of what the .NET devs are working with. So and then we can proceed with the normal workflow, only now the architecture has been built by the front-end dev, so they're totally in control. So let me show you now, once we've gone connected, how the workflow looks for a front-end dev. So here I have a config file which points me to a remote Cycler instance. And I recorded this demo because I didn't trust the Wi-Fi. But instead of running JSS start, I now ran JSS start connected. So what this does, it still starts me on localhost 3000, but instead of pulling data from my local manifest file, it's pulling in data from that remote Cycler instance. And we see that the events I'm seeing now look different. It's not just the repetitive events that were in my manifest, it's actually all unique events. And I know this is working, that it's from the real back end, because I can go and do some personalization. I can go and say that my favorite type of sporting event is basketball, and then I'll see that now it's just only showing me basketball events. So this is because the content author set up those personalization rules on the back end. Furthermore, if I actually grab this URL and go to the back end, I can prove that this local data that I'm working with is actually dynamic data, because I can go and change something. So I can go into, this is what the author would see. So they would actually be able to edit the page and see my React components in this interface, but they can edit them and add them or modify them and change fields and change content. So I just added a second navigation component just because I don't have that many components here to work with. And then once I save it and reload my localhost 3000, I see that now I have 2 navigation components here as well. And conversely, if I start changing my code locally, I would see those changes reflected back in the remote Psycho server, because although the layout data is coming from the remote platform, it's using the Node server on my machine to render the app. So now let's talk about, we've talked about the workflow for the developer, the disconnected mode, and we've talked about the workflow for what it's like to build for the editor. So let's talk a little bit about building for the end user. So for the end user, since we didn't have to wrap the HTML generated by the server-side rendering in any extra bits, we realized that Node was just doing all of the work, and there's no reason why we couldn't externalize that Node rendering, separately and put it on a different server. There's no reason why Node can't be our edge, and why it can't be the one taking the requests and proxying them back to layout service. And this makes it really great because this makes our platform truly headless. The browser has no idea what's actually, it's talking to Node directly, so it just thinks it's talking to an API. It has no idea what's happening on the back end. So the biggest hurdle in this architecture was cookies, because all the personalization and dynamic stuff I showed are driven by cookies. So we found some middleware that helped us overcome this challenge. It worked with Express, and it was able to preserve cookies in the way that we needed, with rewriting origins in a safe and secure way. It was really neat to see this headless architecture snap into place and see all the session state maintained on the back end, since this opened up our platform to tracking a single user session across all different channels. So in our JSS code, just quickly showing, so this right here. Yeah, so in the JSS proxy module, this is the Node module that we use for the middleware, and it's a really light wrapper that we have here around this middleware. And I just want to show real quickly, if you guys end up using this, the change origin was really, the change origin on line 435 was really key for preserving cookies. And then the on proxy res on 439, so that's what takes the request from the end user, and we can write it to look like however we want. So React, for example, or front-end apps in general, have their own way of doing routing. Since our backend still is compatible with MVC routing, and React, it's not a single-page app like on the back end. So we have to do some transformations to how the routes are handled. So we're doing that here. So once we got to tech preview, we had the architecture pretty much ironed out. So now it was time to go beyond React and started looking to support the other frameworks. One of the things we did was in our starters, we added style guides to show examples of the common things that people did in those frameworks. Like, for example, in React, and sorry that I keep talking about React, it's the one I know, how to use render props and higher order components. That was also one of the main feedback that we got from our community, is give us more examples, since we have so many .NET devs that they weren't really sure what to do with this new thing, and they just wanted to see more examples of how to work with this. So the other thing that the community told us about was that they wanted us to refactor to TypeScript. So that's another big takeaway from this phase in the project. I really like this quote. I think it really captures the spirit of front-end devs. So being able to clone a repo, run an npm install, and run a wide-share browser syncing task and get right to work, that's my jam. That feels like a modern, well-done front-end developer workflow. So the point there is that front-end devs love automation. So what we did for that is during tech preview, we added a CLI, a command line interface, and you can use it to create new apps, to add components, to start your disconnected development, to deploy apps and do the import. And just a quick demo here of what it's like to create a new app that uses JSS. It's 3 commands once you have the CLI installed. JSS create, then your app name, and then the framework of your choice. So, and the framework of your choice, I used React here. What that does is pull from one of our sample apps and uses that as your starter. You can also build your own starters. So you can, instead of saying React there, you could say a path to your GitHub or a local file system. So this just makes it very, very, very flexible for creating new apps. And basically, the feedback that we got from people is, if you want to be a real framework, you have to have a CLI. So we listened. So when you create a new app, there's our style guide. We put that in the starter, and it shows you all the different fields, all the different helpers that it has. This was something the community asked for. So in addition to having a site with documentation, they asked for actual code examples of how to do stuff right there in your starter that they can copy and paste from. We used Yargs to implement our CLI. It has some really advanced features. So if you look in the command module part of their documentation, that handles a lot of it. So let's talk about the starter kits a little bit. So we have starter kits for every framework. So they provide an implementation starting point, and they provide the most common functionality, such as routing and internationalization. So just things that in our line of work, devs most commonly work with. We base them on the starter apps in those frameworks. So Create React app, Vue CLI, Angular CLI. And the good thing about them is that not only do they make life easier for the devs who use them, but as you saw with the style guide, they act as living documentation for what our libraries do. So that means that we, the dev team, can use them for testing. So we actually use them in our end-to-end testing, which I'll show in a second as well. What I want to say is be careful not to add too much bulk to your starters, because when you're supporting multiple frameworks, not only do you have to stay on top of all the changes happening in the actual front-end frameworks, but you also have to stay on top of all the changes happening in the starter kits that you're extending. When these starter kits get upgraded, the migration paths aren't always published right away. So that adds some overhead. For example, our starters have a dependency on Apollo because we want to show examples of how to use GraphQL. And Apollo is a dependency that comes with a lot of overhead. They're constantly iterating and making changes to improve performance. So we have to stay up to speed and test for breaking changes. So this is the testing that we built based on our starters. So, and this is, okay, so I have to find my mouse again and show this. All right, app, JSS. Okay, So we used Cypress, which is an actual open source framework that y'all can all use. And so Cypress, so what do we do? Since the style guides have hid all the functionality that is expected to work in JSS. So with Cypress, we spin up all of the pages in our sample apps, and then we go through all the components that we expect to be on those pages and making sure they're there and they're working. So it's smoke testing for all of the features, but it hits all of the sample apps, so it's smoke testing for all the features in every framework. Now, at first, every time that we were adding a feature, we were running this manually on the different frameworks, but also you have to test the framework in disconnected mode and connected mode, and there ended up being this big matrix of stuff we had to test. So if I can get my mouse again, there it is. So what we did is we ended up writing what we call Smokey, which is just a set of custom PowerShell scripts that executes automated smoke testing. So it basically tests the whole JSS infrastructure, and this can be called when a pull request is merged. And so this made life really easy for us. So if I go to packages. Here it is. So this is all of the different environment variations. So for example, if I want to test in disconnected mode with server-side rendering, with GraphQL, in Vue, I just pass in these parameters now to this command, and so all of these tests are run by, these are run by Cypress, but what Smokey does is it installs everything from scratch on a totally empty environment. So it's going to install all the node packages that we depend on. It's going to install our CLI from scratch. It's going to build the manifest for our apps and deploy them. It's going to run the Cypress test on the sample apps. It's going to make sure everything passes. And I don't have time to go through all of these, but this is all open source, so you can take a look through exactly how we're doing this. And this made our testing a lot easier. It made it, since we're open sourced, it made taking contributions from the community a lot more realistic. So finally, I'm sure a lot of people, most people have heard of GraphQL by now, but I don't think everyone has used it. But from our experience, if you're building a framework that is targeted for front-end devs, it should be using GraphQL on the back end. It really empowers front-end devs. They don't need to go to and ask for back-end changes every time there's something changing in the design, because once the GraphQL is implemented on the back end, then you are totally in control of the query. You can ask for whatever you want. You're not overfetching or underfetching. I think I have an example in the next slide. Yeah, so this is an actual query that I ran across that demo site with the events. So on the left, you can see my mouse, great. So I'm actually running two queries in one request. So in the first one, I'm asking for a specific item that's in this path, and I'm only asking for its name property. And then in the same request, I'm doing a search. And in the search, I'm filtering by certain page types, and then pages that start with a certain route. And then I'm saying that in the results, I only want these properties. So normally, I mean, to get a specific page and then to do a search, and then for every search result to get the details of the result, that would require multiple calls back to the server. But you can do this in a single request, and you are specifying exactly what you need based on your requirements of what you want to show on the front end. And GraphQL is self-documenting, so you can click on these queries and these properties, and there's a little docs window that would open that explained the API and actually what you can run. So as a front-end dev, I mean, I love this. And then it can be used, a query like this in this graphical interface. It can be used exactly like this in your code with the help of something like Apollo. So it's very easy to get going with. There we go. So at first, since we were just supporting React in the beginning, we only had 2 or 3 packages. And then as we were adding more support, our repository grew, and that's when we made the choice to move to our Monorepo. We're really happy with that choice. So some of the benefits that we've seen is simpler organization. So it's easier to navigate, easier to reorganize however you want as the project evolves. The dependencies are easier to manage. So stuff like packaging, linting, code formatting, all of the things that you don't want to redefine across projects. And then the cons that I've seen people mention on the internet is tags are less useful, because when you tag something in your source control, it spans for the whole entire code base, but you might just be changing something in one package. We're okay with that compromise since we don't version things by package. We push out just a release for the whole entire JSS code base. It would just be too crazy to manage a version matrix of every package. I think if you have a library with a whole bunch of different packages, it's okay to version them all. And then the other thing mentioned always is performance issues. We haven't seen that at all. Everything is still super fast. I think that only comes as a problem when you're super giant, something like Facebook. So we use something called Lerna to help us with our Monorepo. It's a tool for managing projects with multiple packages. So check out their GitHub if that's something your project is doing. It allows you to manage your project in one of 2 modes, fixed or independent. So with independent, you can version each package by itself, where you're using fixed, where you just specify lerna.js like that at the root of your project, and you specify the version. And so Lerna comes with a lot of out-of-the-box magic. So one of them is this publish command, and so when you run that, what it will do is it prompts you to update your version number. It publishes your packages for you to npm. It updates package.json for you. It makes the commit to master and creates a tag for you. So just a lot of the tedious maintenance stuff that could be easy to mess up across so many packages, it does that for you. It's a really great tool. So I mentioned that the refactoring to TypeScript is something that came out of community feedback. So TypeScript is just king now. The benefits are IntelliSense. So as consumers of our app, whenever they're working with, whenever they require our packages and then they're working with the API, they just get a lot of helpful comments about what the APIs do. It's especially if you're coming from the back end, you're used to this, so it's great. And then for supporting Angular, this was a must since Angular is written in TypeScript. So for other TypeScript consumers, this made the integration easier. So finally, because this project was driven by devs, I'm proud to say that documentation did not get cut from scope. And I won't stay up here and waste time talking about how to write documentation. We all know good docs when we see them. But I wanted to point out that if your project has documentation, it really helps to make it searchable. And there's a free service by Algolia that they will crawl your docs and have this search box for you. It's all free. It's very fast. It's wonderful. You should use it. So in summary, supporting multiple frameworks comes with a lot of overhead. So that the manifest generation feature that I showed, I mean, that started out being totally automatic. When we were just working with React, we were doing that all by just introspecting your components and looking at the React validation and just, you know, and generating that just based on your components. And then when we had to support multiple frameworks, we had to go to a framework agnostic way of doing that. So now it had to be an API. So it couldn't be automatic. So now front-end devs have to actually do the work of creating those YAML or JSON files. So it's a little bit more work for them. We had to refactor to Monorepo since there were more packages in our solution. We had to build some automated end-to-end testing because there were just so many scenarios to support. So there's the overhead of keeping up not only with the changes in the front-end frameworks, but also in the changes with the CLIs that we're extending, Create React App, Angular CLI, and Vue CLI. Then for all the changes that happens in the CLIs, we have to update our starter apps. And those are themselves individual projects. And when you update the starter apps, you have to update the end-to-end testing. You have to update the scripts in the starter apps. It like starts this whole chain reaction. And then of course, there's a whole lot more documentation needed when there's multiple frameworks being supported. In building our JavaScript layer, we wanted to make sure we're building something that JavaScript devs will actually want to use. And we think we've achieved that. So to make it intuitive to use, we added a CLI, TypeScript definitions, a comprehensive searchable documentation, and a quick start guide where you can get up and running in just 3 commands. So that's what I demoed earlier. We empowered front-end devs with a GraphQL integration so they can be in control of the AJAX calls to the back end. We made manifest-driven data modeling so they can be in charge of the information architecture. They don't need to learn how things work on the back end or wait for the .NET devs to define stuff. They can work with any framework, any operating system, any code editor. So if you're interested in learning more about our repository in our project, well, there's our repository. We have a free developer trial that will let you try things out in disconnected mode, and then it will give you a temporary pre-configured Azure instance of our platform to try the connected mode. And then, of course, there's our docs that have a lot of information, have the quick start guide, which is really neat. And that's it.